We are taking a question and answer on digital signal and analog signal. There are different kinds of questions that we are going to take. The first question is, the two basic types of signals are analog and the answer is digital, of course. But before we take these two types, what are signals? Anything which make use of the physical phenomena or the physical medium in order to convey the message or send the information. So that is, anything is a function of time, and that function of time, the continuous variability which is naturally occurring, any phenomena like waving your hand, lightning, or you are moving your vehicle, all these signals are analog only. So analog is the basic signal which you find everywhere in this world. Like this, you see a continuous signal, there is no break. I am speaking right now. If you take this audio signal and convert it into some waveform, this is the waveform. You see AM, FM, all these are continuous, non-discrete wave. But in order to compensate the requirement of computer and the various buses it uses, the network devices we have, all these are digital and they only understand 0 and 1. So the analog signals can be converted into digital signal. These digital signal are simply zeros and ones. Okay. So computer and all the digital devices, they only know 0 and 1. Analog signal are having continuous value. For example, if you represent a sine wave like A sin omega t, whatever you put in omega t, omega refer to the frequency 2 pi f. So there will be various values of sine, and in front of sine omega t there is amplitude. So that is how a waveform is being formed, and you take the samples of this analog signal and quantize it. That will give you the digital signal. So there are two types of signals: analog, this one left one, and digital, the right one. And they both are the core of your electronics and telecommunication and digital electronics. So once again, analog signals are continuous variation of current and voltage, while the digital signals, they only take the discrete value of 0 and 1. Now this 0 and 1 is nothing but the voltage which is transferred. For example, if you send through a wire or without a wire a 0 voltage, that 0 voltage corresponds to 0. If you send plus 5 voltage, for example, that corresponds to a value 1. So everything is voltage, either it is analog or digital, and they all are conveying information, taking the data of the real life and converting it to the form so that it can be conveyed or it can be sent as an information. Which option below lists the type of signal denoted by a sine wave? Now sine wave you might have seen in the mathematics. It's simply all the values of sine angle it takes from 0 to 360 degree and others, so that you get a value between -1 and 1. So the amplitude is 1 and -1 here. There is a wave. You might have seen the wave in different arena like in sea. So if you are able to represent it in the form of say x and y axis, you see a time. On x-axis, y-axis, we have certain value, for example, voltage. So this sine wave, there is no breakage. It is continuous. Sine wave and cos theta waves all are continuous. For every value of t in this case, you'll get some value of v. V can be any value. It can be voltage. So every x will have y value. So it will be a continuous infinite value kind of representation. So this is a sine wave representing the analog signal. Everything in this world is analog. Which option below lists the type of signal denoted by binaries 1s and 0s? So if you have a 1 or a 0, then this type of signals carrying only this information And see, computer and all these digital devices, they only understand bits. So list the type of signal denoted by binaries, ones and zeros. It's of course digital. Digital is like your switch in your house. You switch on and you switch off. Switch on means you are actually talking about 0 voltage. Switch on, you are talking about say plus 5 voltage. So this is how 0 and 1 are formed. Okay. Then we have the digital scenario. And since in digital scenario, as I'm again and again talking about the voltages. So this is the representation of 0 and 1. Don't think that this is continuous. It is discrete in nature. Only 0 and 1. 0, 1, 0, 1 like this. So this is not continuous. This green line, you see it is continuous. But this is only the line, red line which I am making is representing the signal. Which is a digital signal, only ones and zeros. An analog signal is continuous in both. The answer is time and amplitude. So this is the x-axis time. This is the y-axis. It can be any value. Let us take voltage here for example. So you have x-axis and y-axis. Now you see this is the uppermost and the lowermost extent is called the amplitude. And now you see this amplitude is varying with respect to time. If time is varying, the amplitude is also varying. Because if you represent a sine wave or a signal using a sine omega t, this is the normal representation. Omega is basically frequency 2 pi f. So you are giving the value inside sine and there is an amplitude outside. So whatever value you get from -1 to 1, because sine omega t can give you only -1 to 1. So all the extent, highest extent and lower extent, you will get everything every time. That is the continuity will be maintained. So every t value will give you some value of v. So right on the x-axis you are getting time. And with the time variation, amplitude is also varying. That is why the analog signal is continuous in both time and amplitude. Analog signal is a measured response to changes in a. Now it can be, the definition of analog signals is based on a physical phenomena. Everything in the world is analog. So if a kid is singing or shouting, now there are certain audio waves. That is, the physical phenomena is disturbed because of the sound or the pressure or the energy which is coming out of your mouth. And that is an information. That is the data and that can be converted into a meaningful information. So if you convert this, whatever I am speaking, into audio signals, these audio signals are nothing but the analog signals. So analog signal is actually measuring the response to changes in the physical phenomena. And the physical wave phenomena is here the sound, the air, the sound waves, which are carrying the energy produced by your mouth. Alright. So the pressure you give more on the mic, more pitch, more loudness and more amplitude of the signal will become. And if you are speaking a bit, not that loud or slowly, the amplitude will be lower. So the physical phenomena is the actual answer for this analog signal, which is measured. It is measuring the response to changes in the physical phenomena. Even if you go to say some water, and then you start saying something, that is also you are using physical phenomena. Dash is both discrete and quantized. Discrete and quantized, that you have to understand. First of all, this blue line which you see is the analog signal, because in world everything is continuous. When you have taken birth, your heart is pumping from your birth till the last breath you will take in this world. So this is an analog signal which will go on and on again and again. Okay. Now the computers and everything in the digital scenario, they only understand the ones and zeros. So what we do, we take from this blue line some samples. When we take the sample, it can be any value, say, because there is a sine wave and it only takes maximum value and minimum value. Okay. Now what you do is you take sample and then you quantize it for 0 and 1, right? sampling and quantization of the analog signal is taken. For example, you get some 0.5 value or 0.6 value. 0.6 can correspond to 1 and 0.4 can correspond to 0. And these are nothing but the voltage levels. So actually you are taking the voltage level and converting all the continuous voltage level. You are taking certain voltage level and converting them into, or regarding them or indicating them as zeros and one depending upon its extremity. That is, they are lower, you can call them as 0. They are higher, you call them as 1. Okay. That is why you only get certain values for certain x, certain y value. You will not get all the y values for all the x. That is why it is discrete and quantized. Analog signal, the key feature of analog signal that it has to be continuous. It should give you infinite values. It should be naturally occurring, and there has to be a waveform which it needs to be followed, not exactly sine wave, but certain waveform which has to be continuous. Okay, so all the three pictures you see here, they all are analog signal because there is no breakage. There is no breakage. They are non-discrete and they are continuous value. For every x value, you should get some y value. For every time value, you should get some voltage value. Alright? And this is not always like this. If you see the middle one, it is not the waveform of sine or cos. It is almost different. So an analog signal is continuous and it can take infinite values. So if I make a graph out of it, for every x value, you will get a y value. For every x, you will get a y value. The output form of an analog signal can be any curve, any line, or it can be any graph also. And this is because it shows the continuity. If you take your bike or a car and if you start it and attain an average speed and keep that speed all through your journey, then this average speed is also an example of analog signal, but it is not wave. This is a straight line. So analog signal, this has to be defined, or it can be defined by three things. There are various parameters, but the key features are amplitude, the frequency and the phase. The amplitude is the highest and lowest point. The frequency is in 1 second how many waves can you see, or how many crest and trough you can see. The distance between crests and difference between the troughs, this becomes the amplitude sorry. And then the phase is the starting angle from where the x and y axis meet, that is 0, 0. What is the angle of the wave? So the other wave, when you superimpose it over the previous wave, the angle difference is called the phase difference. Which of the following characterizes an analog quantity? The option first of all is it has a continuous set of values over a given range. Now you might have embarked, or so you can say fixed this thing in your mind now, that analog means a continuous set of value, or analog signal means continuity. And it has to be defined, or it can be defined because it is a form of wave, continuous wave. Then the amplitude, wavelength and phase are those which can define an analog quantity. See, analog quantity is different, analog signals are different. Analog quantity, it has a continuous set of values over a given range. So an analog signal is continuous, can take infinite values. It can be defined by amplitude, frequency and phase. And the curve can be anything. It has to be continuous only. Which type of signal is represented by discrete values? Now, discrete means only certain values, not all the values. So for one x, you get one y. For example, you take time on x-axis, voltage on y-axis. So this is the continuity if you make like this. But if you take certain values only, that are discrete values. Okay. So these discrete values are only with respect to digital signal. As I said, analog signals are continuous. We can use the analog to digital converter using the science of sampling and quantization. That continuous signal can be converted into digital signal. Okay. But digital signal also can be defined using the amplitude, phase and frequency. How? Because the digital signal can also be represented as harmonics. But in all, the discrete value is like this. You switch on, 0 voltage is 0. You switch on 5 voltage, plus 5 voltage is 1. You switch off, a 0 voltage is 0. Okay. So you see the digital are converted only from the analog signal only. A data conversion system may be used to interface a digital computer system too. So digital computer system, that means it will take 0 and 1. It is talking about a data conversion system that may be used to interface a digital computer system to what? So you have a wave, you are taking samples here and you are taking the samples and quantizing it. So basically you are discretizing it. That is how the discrete value will come. So what is the data conversion system for it? It is an analog output device. So there are two things, analog to digital converter in order to convert the analog signal into digital signal, and then digital to analog, take the digital signal, it will give you the analog signal. So there are different conversion systems like this. Digitizing a signal converts it from digital to analog. Now this is false, this is false. Because digitizing means only that you have infinite values, continuous set of values, and you are taking certain values out of it in order to make it discontinuous and discrete so that it can be sent with respect to different voltages. Okay, so you have this blue line which is corresponding to your analog signal, and from this analog signal, this step which you see are the samples being taken, and this is the stepwise, that is why this is discrete. And all these values can only take certain values, that is 0 and 1, and that 0 and 1 only comes after sampling and quantization. The voltages in digital electronics are continuous variable. Now this is very true, because only voltage change can be seen on the other side as an incoming of a signal. So this is different voltages you see in this picture. Different voltages can correspond to different values, and that different voltages corresponding to different values are nothing but the digital signals. So the voltage in digital electronics, they are continuous variable. It is untrue. They are non-continuous variables. In digital electronic circuits, information is first converted to a coded group of pulses. Now this is absolutely true. I'll show you a picture and then you will realize that how in digital electronic circuit the information is first converted into a coded group of pulses. So this is an analog signal. Sine wave is also an analog signal. All signal naturally occurring, continuous and non-discrete, and can be defined by phase, amplitude and frequency are called as analog signals. Now first we have to convert it into the coded group of pulses, and these are nothing but you are taking the samples. So you are taking certain samples which I am highlighting here, and finally this last one is nothing but the coded group of pulses. It can be PAM, it can be PCM, pulse code modulation, like this. So if I can tell you pulse code modulation, that means you are talking about coded group of pulse. Okay, so the answer here is true. In digital electronic circuit, information has to be first converted to this kind of coded group of pulses so that you can get a digital signals out of the analog signals. The decimal code system uses 10 levels of voltage. The answer is true. Now I can show you a table where you see the voltages, different voltages, and it can be interpreted as different values. As I said, the digital signals are nothing but the discrete signals. For example, for the whole range of 0.1 to 1, you can comprehend or think that the value is 0. Okay, so the answer is true here. Sensor outputs destined for a digital computer system must first be processed by. So you have a sensor. Sensor is a physical device which senses certain physical parameter convert into digital signals and then transfers it. For example, how does the Google knows where the traffic is, where the traffic is not, which road is closed? All this is because of different information through sensor information. So this sensor information destined for a digital computer system must first be processed by analog to digital converter. Analog signals are continuous. You need to convert it into discrete and discontinuous. So the answer is analog to digital computer or converter. Hope you have a better idea of digital signal and analog signal now. Thank you so much. Take care of yourself.